Welcome to the world of mirrors. Before I start, let me show you some mirrors you see in your daily life. This is a rear view mirror where you can see the cars as small images. This is a convex mirror which is used as a rear view mirror. Another one, this is security mirror which is used in shops where again you can see the images in smaller size. Convex mirror again. This is shaving mirror where you can see the image much bigger than the object. It's a concave mirror which gives you bigger images. This is the headlight of a car where cave mirror is used. This is the lighthouse where again a cave mirror is used. This is a cylindrical mirror which gives you distorted image, and this is the normal plane mirror which you see your image on a daily basis. And we begin the topic light from grade 10 CBSE, and by the end of this video you will have a clear idea on what's a plane mirror, how does a plane mirror form its image, then what is reflection. There are two different types of reflections. One is regular reflection and the other is irregular reflection. The difference between the two you will learn. Then the characteristics of an image formed by a plane mirror. We will talk on spherical mirrors. There are certain terms related with spherical mirrors. We will learn all those terms. And then we will do some numerical questions. To begin with, reflection. Look at this image. It's a room where you can see light is coming from the bulb on the top, and you can see light passes in all directions. And look at one of the light rays. The light ray falls on the computer, and from which you can see it bounces back. It is reflected back. And if it falls into your eyes, you will be able to see the computer. Let's see what is light. Light is a form of energy which produces the sensation of vision. Without light, you won't be able to see anything. So light helps you to see things. Let's see a property of light, which is rectilinear propagation. Rectilinear means straight line, and look at this, light travels in straight line. This is the meaning of rectilinear propagation of light. And look at this picture. This is a plane mirror. Left side of this plane mirror is reflecting surface and the right side is painted. And see, the light comes from the left. Imagine a laser beam is coming from left and it strikes on the reflecting surface. This laser beam, we call it as incident ray. Why do we call it as incident ray? Because it falls on the mirror. And after falling on the mirror, it bounces back, and the bouncing ray, we call it as reflected ray. Incident ray is the one which falls on the mirror, and the reflected ray is the one which bounces back. Reflection means bouncing back. The white dotted one, we call it as normal. Why do I call it as normal? Because that white line makes an angle 90 with the reflecting surface. And look at this. This angle, we call it as angle of incidence, which is written by a letter I. And look at the other angle, which is between the reflected ray and the normal, right with letter R, we call it as angle of reflection. Quick, angle of incidence is the angle between the incident ray and the normal. And angle of reflection is the angle between the normal and the reflected ray. And look at this picture. Are they equal? Yes, you will see they are equal, which means angle of incidence is equal to angle of reflection, which we call it as law of reflection. So the first law of reflection is the angle of incidence is equal to the angle of reflection. And there is one more rule. Look at the purple ones I drew over here. All of them are on a single plane, which means the incident ray, the reflected ray, and normal to the point of incidence all lie on the same plane. That is the second law of reflection. How do we make a plane mirror? Take a plain glass sheet, paint one side of the glass sheet with silver, which forms a reflecting surface, turn it and paint red color opaque material on the other side and turn it, and this forms the reflecting surface. And how do you draw a plane mirror in your exam paper? The way we draw the plane mirror is just like this. The reflecting surface is drawn with a single straight line, and the behind part, the opaque surface, is shown just like that. Let's see different types of reflections. First one is regular reflection. What is regular reflection? Imagine a mirror which is a smooth surface and you allow the rays to fall on it. Look at these rays. These rays are really parallel. And after reflection, what happens? The rays are becoming parallel again. So in regular reflection, the reflected rays are parallel after reflection. Reflection from smooth surfaces like plain glass, still water are examples of regular reflection. Now, let's see what's irregular reflection. Reflection from a rough surface like a piece of paper is irregular reflection. You can see parallel rays fall. Do you expect these rays parallel after reflection? No, they move in different directions. So this is irregular reflection. Regular reflection gives you a clear image. Irregular reflection doesn't give a clear image. Simple example, regular reflection is from a plain mirror. You can see the image in a plain mirror or in a plain glass piece. But irregular reflection takes place from a piece of paper where you won't see your images. Why you don't see your images? Because it is irregular reflections. What are the characteristics of image formed by a plane mirror? Let's see the first characteristics. The image formed by a plane mirror is erect and of same size. Erect means upright. See, this is you standing in front of the mirror, and look at the image formed by the plane mirror. Same size. Your head is on top, erect. That's it. Second characteristics. The image is same distance behind the mirror as the object is in front of it. Look at this. The object is 2 meters in front of the mirror. And where will you see the image? 2 meters behind. So if it's a chessboard, if the object is 2 boxes in front of the mirror, the image is seen exactly 2 boxes behind the mirror. Third characteristics. The image from a plane mirror is laterally inverted. What does laterally inverted mean? See, you are the object, you are lifting your left hand and you will see the image is raising its right hand. It is just laterally inverted. And if I write a letter B in front of a mirror, the image you see on the mirror will be something like this, opposite. So if I write AB, it will be something just like that. AB. This is the meaning of laterally inverted. Let's do a simple question. A robot is standing 8 meters exactly in front of a plane mirror. Where will you see its image? Same distance, it is 8 meters. The question can be the another way, how far the image is from the object. This is 8, this is another 8, so the final answer will be 16 meters. That's it. Second part of the question, if the robot moves 2 meters towards the mirror, where will the image be? He was 8 meters before, and when he moves 2 meters, now he will be just 6 meters, and where the image will be another 6 meters. So the distance between the object and the image will be 12 meters. That's it. Next is another type of mirrors, which is spherical mirror. There are 2 types of spherical mirrors. The first one is convex mirror and the second one is concave mirror. Always convex mirror gives you smaller images, but concave mirror can give you larger image. And how do you make a spherical mirror? Imagine this is a glass ball. You cut the glass ball into a small piece, and if you paint outside of the bulging part with an opaque material and paint inside with silver, the reflecting surface is inside, which forms a concave mirror. Now, do the same thing. You paint opaque material inside and silver on outside. The reflecting surface is outer surface. Then it forms a convex mirror. And how do you draw them? The same spherical glass ball, you cut it into a small piece and you paint inside with opaque material, and then reflecting surface is the outside surface. It forms a convex mirror. And for concave mirror, do the same thing. Paint opaque material on the outside surface and silver on the inside surface. It forms a curved mirror. So this is a concave mirror where the reflecting surface is inside and the opaque surface is outside. And for a convex mirror, reflecting surface is outside and the opaque surface is inside. Look at this. Parallel rays fall on a convex mirror. What happens? You can see the reflecting surface is kind of diverging type. The reflected rays are also diverging. So another name for convex mirror is diverging mirror. Why is it called diverging mirror? Because the parallel rays diverge, move further away from each other. Opposite for concave mirror, parallel rays fall. Look at the reflecting surface, it is kind of curved inwards. So rays after reflection will converge to a point. So we call it as converging mirror. So difference between the two, convex mirror is called a diverging mirror because it diverges the rays further away. And concave mirror is called converging mirror because it converges the rays towards a single point. We move on to some common terms which is used to specify a mirror. Look at, it's a transparent glass sphere which is cut into two pieces. Look at this. Reflecting surface is convex, we call it as convex mirror. Reflecting surface is concave, we call it as concave mirror. The center of the sphere, we call it as center of curvature. So what is center of curvature? It is the center of the sphere from which the mirror is formed. Now, just focusing only on concave mirror, I am talking about the pole of the mirror. The midpoint of the mirror, we call it as pole. The exact geometric center of the mirror, we call it as pole. Now, move on to principal axis, which is a straight line passing through the center of curve and the pole. A line through C and P is called principal axis. Radius of curvature. It is the radius of the sphere from which this mirror is formed. Principal focus. It's a concave mirror, center of curvature, pole, the principal axis, and I am drawing parallel rays. What happens to the parallel rays? Reflecting surface is concave. We call it as concave mirror. Converging mirror. All the rays converge to a point. That point we call it as principal focus of a cave mirror. So how do we define principal focus of a concave mirror? It is a point on the principal axis where all the parallel rays after reflection meet. So point on the principal axis where all the parallel rays meet after reflection. We do the same for convex mirror, center of the mirror, pole of the mirror, principal axis. I am drawing parallel rays. You can see the reflecting surface is diverging. So all the rays diverge. They don't meet. But all these rays are coming from a point on the principal axis. See, this rays we feel coming from there. This ray is also coming from there. This point we call it as principal focus of a convex mirror. So how do we define principal focus of a convex mirror? It's a point on the principal axis where all the parallel rays after reflection from the appear to diverge. We feel all these rays are coming from that point. So we call that point on the principal axis where all these rays appear to diverge. We call it as principal focus of convex mirror. And this is really happening in case of concave mirror. So we call it as real focus because you can see rays really converge at that point. This point in case of convex mirror, we call it as virtual focus, which is not real. It appears to diverge from that point. So it's not real. We call it as virtual focus. And the last, focal length. What is focal length? It is the distance between principal focus and pole of the mirror. Now, how does radius of curvature related with principal focus? If you look at this picture, this is focal length, this is also focal length, and the whole distance is radius of curvature. So 2 times focal length gives you radius of curvature, or the reverse. Focal length will be radius of curvature divided by 2. R can be written as either 2f or f can be written as r divided by 2. Let's do some questions. Simple questions. They want the focal length of a convex mirror whose radius is given as 32 centimeter. Let's write the given things. Radius of curvature is given as 32 centimeter. And what do they want? They wanted the focal length. And what is the formula we are going to use? F equals r by 2. R how much? 32. And divided by 2, which will give you 16 centimeter. Simple. So focal length of the mirror is 16 centimeter. Another similar question. They gave you focal length 20 centimeter. And what do they want? They wanted the radius of curvature. Let's see. Given things, focal length f equals 20 centimeter. And they wanted the radius of curvature r. And the formula we use is f equals r by 2. Rewriting r equals 2 times f. 2 times, how much is f? 20. So 2 times 20, 40 centimeter is the radius of the mirror.